The process of a request coming from a client, going through AWS Istio, and reaching the application pod in a Kubernetes cluster can be complex. Below are the detailed steps involved in this flow. 1. Client request. The client sends a request to a specific domain or IP address. This request could be for a web page, API data, or any other resource hosted on your application running in a Kubernetes cluster. However, 2. AWS Gateway, API Gateway, or Elastic Load Balancer. The request is first routed to the AWS Gateway, which could be either an API Gateway for API-based services or an Elastic Load Balancer, ELB, for other types of traffic. API Gateway, or ELB, acts as the front door to the services, managing the external traffic and ensuring that it's correctly routed into the Kubernetes cluster. It balances incoming traffic across the available nodes or instances running your Kubernetes pods. 3. Load Balancer to Kubernetes Ingress. The load balancer routes the traffic to the Kubernetes Ingress Gateway service, which acts as the entry point for external traffic into the cluster. In this case, Istio Ingress Gateway, part of Istio's service mesh, receives the request. Istio's gateway manages routing rules, security, and more before passing the request further into the cluster. 4. Istio Ingress Gateway. The Istio Ingress Gateway receives the request and applies any configured policies, including authentication, authorization, and load balancing. Istio also manages routing rules based on the destination host or URL path. Istio provides a service mesh that can monitor, route, and control the flow of network traffic between services. The Ingress Gateway then forwards the request to the appropriate service or pod in the cluster based on routing rules defined in virtual service and destination rule configurations. Hop 5. Istio Proxy, Sidecar Proxy. The request hits the Istio Sidecar Proxy, often based on Envoy, that is attached to each pod. The proxy can handle additional security policies, traffic splitting, retries, or timeouts. The Sidecar Proxy routes the request to the correct container within the pod. 6. Request reaches application pod. Finally, the request reaches the intended application pod that hosts the application, microservice, or API that needs to process the request. The application processes the request, e.g., querying the database, performing computations, and generates a response. 7. Response travels back. The response travels back through the Sidecar Proxy. It passes back through the Istio Ingress Gateway, or API Gateway ELB, before being routed back to the client via the AWS infrastructure. During the response, Istio can handle logging, metrics collection, and monitoring to ensure that the traffic is behaving correctly and without issues.